Hello, I will present about CloudBear's RISC-V processor IP product line. So currently our product line includes 3 series of cores which targets different applications, from microcontroller applications, which is BM series, Linux capable cores, which is BI series, and high performance compute control and high performance accelerations. BR courses targeted these applications. So I will go through the product line and explain what is the difference. First core, it's a BM310 core, which is a microcontroller comparative with M3, M4 solutions. And it's 3-stage pipeline and includes all necessary peripheral devices like debug controller, interrupt controller. The reference numbers of benchmarks are given here, and it's also have been tested across various third-party AD vendors like AR, Ziegler, Lauterbach, to enable debugging in different professional ADs which are available in the market for RISC-V today. It already has implementation cases. So here is example of the case for the customer which use this core inside smart metering system. And what customer cares in this case, they goes for high volume and they want to reduce royalty fees. So we provide them solution how to do that, and providing them better performance on Cortex M3 to better analyze this metering, current metering system requirements. And BI series cores are more focused on Linux capable, and we have 3 cores on this product line. It's starting from IoT focus core, which called BI350, and the other side it's high performance autofolder core, which we call BI671, and in the middle something in between in terms of performance and power consumption. It's a high performance core which is more used for power constrained environments. All these cores can be combined into multi-core configuration. So we provide shared layer 2 configuration which can maintain coherency between these cores. And at the same time, we also provide coherency controller to support and maintain coherency between cache subsystems and accelerator devices or peripheral devices that you have in a SOC. At a glance, our highest performance core currently looks like that. So you can see different parameters of internal structure and approximate area, which of course depend on the options you select. Note that it can run 1.2 gigahertz at 28 nanometer and takes about 4.5 millimeter area. Our goal was to provide the core in mid-range performance comparing to existing solutions, so something in between which you can have from i53 to high-end cores like A73 or Sci-Fi U84. So, and this is a representation of Spec 2006 benchmark, which is quite popular to benchmark Linux capable machines, and you can see that performance is pretty much competitive with existing solutions. So currently at the booth you can check out the demo of this Linux core demonstration. It's running Debian Linux on the FPGA prototype, so please drop me a booth if you want to see that. And this core, of course, yes, has advantage that it can be used in a power efficient environment. We call it BI651. And it's competitive with solutions like Cortex A53. You can see the Kemper region with well-known implementations of ARM vendors. And something what we provide for IoT applications. It's core which focus on the very, very tiny area, but still with a Linux capable things. This core can be configured in terms of memory subsystem and in terms of cache line sizes and memory interfaces to be really, really small on your SoC, but still give you capability to run Linux. And what we introduce right now, it's our new product line series. It's BR series. It's more for deeply embedded applications when you need to high performance controller, or you need offloading functions like network functions or AI functions, and want you to embed that in SoC. It includes some TCM memories for fast data access, caches. Depend on your need, you can configure that core. If you need these caches or need TCMs or need extensions, all this can be disabled or enabled, depend on your need. And some numbers are given here for 32 and 64-bit version of this core. So that's example how one of our customers are using it. So it's industrial automation SOC, which is based on dual core configuration of BR351, and one core was working on industrial Ethernet applications, where important thing is the latency. So you need to feed the data through industrial Ethernet quickly to the TCM memories of the cores, and then quickly process it to get a reaction. And second core just doing application work. And some customization things was done for customer in this case to first cut the latency to embedded flash memory. So since this device is running directly from on-chip flash, and it's pretty much slow, so you have to compensate these delays by improving your pre-fetch engines in your instruction cache. And another thing what we customized was latency latency on the front port, which is used for Ethernet block to access the TCM memories of microcontroller. That target was to reduce this latency as much as possible. And of course, we support normal RISC-V things like atomic extensions in this case, and both cores can work together to synchronize with each other, and one core will perform networking work and another application itself, and they can exchange the information. So that's basically the case where the cores, such cores can be used. So that's it from my side. Yeah, please join us on Twitter, and if you have any questions, please ask. Thank you.